Okay, section 7.2 has to do with similar polygons. So similar figures have the same shape, but not necessarily the same size. The symbol to represent similar figures is this little squiggle. Okay, so that means similar. Remember, it's a little bit different than our symbol for being congruent, because that means similar and equal. This just means similar but not equal to. So here's an example. Two polygons are similar polygons if the corresponding angles are congruent and if the lengths of the corresponding sides are proportional. So you can see that A and E are congruent, B and F, D and H, C and G. So we can say that polygon A, B, C, D is similar to polygon E, F, G, H if angle A is congruent to angle E, angle B is congruent to angle F, angle C is congruent to angle G, angle D is congruent to angle H. And you notice I did A, B, C, D in order and E, F, G, H in order. We also have to say that the ratio of A over B to E over F is equal to the ratio B over C to F over G, is equal to the ratio of CD over GH, and the ratio of DA to HE. In other words, these are not equals. AB does not equal EF, but the ratio of A to B, of length AB to EF, is the same as the ratio of BC to FG, etc. So let's take a look at that. So I want to determine if these two triangles are similar. So in other words, is triangle ABC similar to triangle DEF? Now they're not in the same position as the trapezoids on the last page. One of them is spun around, but we should be able to tell as well. Is angle A congruent to angle D? So let's look. Angle A is congruent to D. Yes. Is angle B congruent to angle E? Yes. And is angle C congruent to angle F? And that's true as well. So my angles are all congruent. Now let's look at the ratio of the sides. So I want to look at AB and see if that's congruent to DE. Or excuse me, not congruent. If the ratio of AB to DE is equal to the ratio of BC to EF, which is equal to the ratio of CA to FD. So AB is 12, DE is 15, BC is 16, EF is 20, CA is 8, FD is 10. Are these ratios equivalent? First I'm going to put them in simplified form. When I do, I get 4/5, 4/5, and 4/5. So yes, these are equivalent ratios, so these are similar triangles. It's pretty simple. We're also going to use it to find unknown values if I know that two polygons are similar. So I'm told that ABCD is similar to DEFG. Therefore, the ratios of the side lengths should be equivalent ratios. So I know these two side lengths. I know that AD to ED should be equivalent to the ratio of AB to EF, which should be equivalent of the ratio of BC to FG. I don't need CD and GD because there are no variables or numbers there, so I should have enough information. Alright, AD is 9, and the ratio of 9 to 6, ED, should be equivalent to the ratio of 5 to Y, which should be equivalent to the ratio of 7.5 to X. So let's solve for X. Well, I can compare these two as equivalents. 9 over 6 is equivalent to 7.5 over X. 9x equals 45, therefore x equals 5. So there's one of my values. Using 9 over 6 again, or I could use 7.5 over 5, but I don't like that decimal. So 9 over 6, 5 over y, 9y equals 30, and y equals 30/9, or 10/3. So the length of y is 10/3. So pretty simple stuff. That's it for the whole section. We're done for the day.